Hey everyone, hi, this is Rudransh, and today we will be discussing about exoplanets. We will be knowing about the introduction, its kinds, and examples. Let's start. Now, the first kind is gas giants. Now, gas giants are giant planets composed mainly of gas, just like Jupiter and Saturn. But since we are studying about exoplanets, so the gas giants outside our solar system are considered as exoplanets. Now the second kind is Neptune-like. One of the example is HAT P26b. Now here we can see that Neptune-like are the gaseous world around the size of Neptune. So they have the similar size of Uranus and Neptune, and they are gaseous worlds just like Uranus and Neptune. Third kind is super Earth. One of the examples is 55 Cancri E. A super Earth. It is a potentially rocky world larger than Earth. And the fourth kind is terrestrial, a rocky world outside our solar system. There's a big difference between super Earth and terrestrial that is according to the size of both. Now let's go to the next slide. What is a gas giant? A gas giant is a large planet composed mainly of hydrogen and helium, just like any other gas giants. And in the sun also, these two are the main constituents. The planets like Jupiter and Saturn in our solar system don't have hard surfaces and instead have a swirling gases above the solid core. So this is a solid core, and around this there are several gases. Now, like Jupiter and Saturn, they're gas giants like Kelt 9b and Kepler 7b. They also with solid core and don't have hard surfaces but have swirling gases layer around them. Now we will see an example. One of the examples is Kelt 9b. It was discovered in the year 2017 and the planet type is obviously gas giant. The heat of Kelt 9b is too much even for the molecules to remain intact. For example, these are the molecules, and the heat is so much that they expand too much. That is why they are not intact anymore. The molecules of hydrogen gas are likely ripped apart on the day side of the tidally locked Kelt 9b. So the molecules of hydrogen gas are ripped apart on the day side on the planet Kelt 9b. With the dayside temperature of 7800 degree Fahrenheit, which in SI units is 4600 Kelvin. Kelt 9b is a planet that is hotter than most of the stars, but its star, which is Kelt 9. So Kelt 9b is the planet, and Kelt 9 is the star. Now, Kelt 9b is a gas giant 2.8 times more massive than Jupiter. So this is 2.8 times Jupiter's mass, but it only is half dense because the molecules are ripped apart, because of which the size of the planet increases and the density decreases. So, though it is more massive, but it is only half dense. Scientists would expect the planet to have a smaller radius, but the extreme radiation from the host star has caused the planet's atmosphere to puff up like a balloon. So, the scientists expected the planet to have a smaller area, but due to the extreme radiation from the host star, the planet's atmosphere began to blow like a balloon. That is why it's half dense than Jupiter. Now, as we saw, Kelt 9b revolves around the star Kelt 9. So, Kelt 9 is a B type star, just too faint to be seen with unaided eye from Earth, meaning we can't see from the unaided eye from Earth. This is 667 light years away from us. So, if you travel with the speed of light for 667 years, then only we will be able to reach the Kelt 9 star. Now let's go to the next slide, where we will know about the Neptune-like exoplanets. Neptunian exoplanets. Neptunian exoplanets are similar in size to Neptune or Uranus. Just like we told in the starting, they are similar to the size of Neptune or Uranus. They typically have more hydrogen and helium dominates atmosphere. Just like we saw in gas giants, their atmosphere is mostly containing helium plus hydrogen, but their core, this is made of metal and rocks. So that's the difference. That was only solid, but this one contains metals and rocks. Now let's go to an example, which is HAT P26b. Another example is GJ436b, but we will know about HAT P26b. HAT P26b was discovered in the year 2010. Planet type, as I told, it is a Neptune-like exoplanet. HAT 26PV is a Neptune-like exoplanet that orbits a K-type star. We'll know about the types of stars afterwards. Its mass is 22.24 times of Earth. So it is 22.24 times more massive than Earth. And and the distance of this of HAT P26b from its star is 0.0479 astronomical units. Its discovery was announced in the year 2010, as I told. Now let's see about its star. HAT P26b revolves around the star HAT P26. It looks like the sun. Its distance from the Earth is 436 light years. Just as I told in the example, it would take 436 years for us to reach HAT P26, even though we travel at the speed of light. It is a K-type star, which is too faint to be seen from the unaided eye of Earth. Now, what are super Earths? Super Earths are a class of planets unlike any in our solar system. So they are not in the solar system. They are more massive than Earth. So they are more massive than Earth means their mass is more than Earth, but they are lighter than ice giants like Neptune and Uranus. So they are smaller than Neptune and Uranus as well as lighter, but it is heavier than Earth. This is a combination of gas, rock, or a combination of both. They are twice the size of the Earth and up to 10 times as mass. 2 into the size and 10 times the mass. This is the limit of super Earths. Now let's go to the next slide. Some exam some examples of super Earths are GJ15AB and 55 Cancri-E. We will study about this. So the exoplanet 55 Cancri-E was discovered in the year 2004. It is the planet type of this is super Earth. 55 Cancri-E. This is also known as Janssen. Orbits a star Corpus Copernicus, which is only 41 light years away. Comparing to the 400 and 600 light years away from Earth, this is a very smaller distance. The molten surface is completely uninhabitable. We cannot inhabit the outer surface of 55 Cancri. Jansen's sister planet Galileo hangs in the dark sky. Its sister planet, which is Galileo, hangs in the dark sky. Silicates in the atmosphere, which would condense into the clouds on the tidally locked planet's dark side, reflecting the lava below. So the skies would sparkle. As we can see in the figure, these red spots, is the lava, makes the planet sparkle in the skies. 55 Cancri-E, the super-Earth exoplanet that orbits a G-type star similar to our Sun. So the star of 55 Cancri-E is similar to our Sun. The star's name is Copernicus, just like we could see here. Its mass is 8 times that of Earth, and it only takes zero point 0.7 days to complete one orbit of its star. It is 0.15 astronomical units away from its star. Its discovery was announced in the year 2004. This is the star of 55 Cancri-E. It is known as 55 Cancri or Copernicus. It is 41 light years away from Earth. Oh, it is a K-type star which is visible from the unaided eye of Earth. So we can see it from the unaided eye of Earth. Now let's go to the next slide where we will see the next type of star which is terrestrial. Now let's go to the terrestrial exoplanets. In our solar system, Earth, Mars, Mercury, and Venus, which are the first, second, third, and fourth planets. These are terrestrial or rocky planets. Terrestrial means rocky. For the planets outside of our solar system, since we are studying about exoplanets, so they are outside of our solar system. These planets range from half the Earth's radius and are considered terrestrial, whereas others might even be smaller. So mostly the Earth radius is 6371 kilometers. So by dividing this by 2, we get 3185.5 kilometers. So the radius of terrestrial exoplanets is about this. Now exoplanets might be twice the size of Earth. They can also be twice the size of Earth and maybe super rocky as well. But since they are larger than Earth, so we consider them as super Earths. Now let's see an example. We will see the example of TRAPPIST-1e. TRAPPIST-1e. This was discovered in the year 2017. The planet type of this is terrestrial. TRAPPIST-1e is a terrestrial exoplanet that orbits an M-type star. It orbits an M-type star. Its mass is zero point 0.7 times that of Earth. Its distance from its star is 0.02925 astronomical units from its star. Its discovery was announced in the year 2017. This is the star of TRAPPIST-1e, which is TRAPPIST-1, an M-type star, the most commonly type of star. So we can see that M-type stars are the most common. This type of star is much redder, cooler, and dimmer than our sun. So this is much redder, has a lower temperature, and is dimmer than our sun. Thank you for watching the video. Make sure to like, share, and subscribe.